Welcome students. Today we are going to study cooling curve for materials and it comes under your unit number 3, which is metallurgy, and subject is your materials and metallurgy. After completing this lecture you will be able to explain the cooling curve for materials, what is the purpose for drawing a cooling curve, and what we will get after drawing a cooling curve. So let's start the lecture. So it is a time temperature curve of a material which is cooled from liquid state to the solid state. As you are seeing in the diagram, the material is cooled from point A to point B, and point A to point B the material is in liquid state, and then at point B solidification start, and point B to point C is in liquid plus solid state, and after C it will completely converted into a solid, and at point D is room temperature point. So this is a cooling of a metal from liquid state to the solid state. So in this curve we are going to study the different phases which are present at different temperature of a material, and these phases are studied at different temperatures, and analyze the development of grain or microstructure of a material when cooled down from liquid state to the solid state with different cooling rate. As you are seeing here, the liquid is converted into the metal is converted into liquid state by heating at a high temperature. Then it is cooled down according to the at a desired cooling rate according to the property you required in your material, and gets converted into solid state. So in this part we are going to study the cooling curve for a metal, and as you seen in the diagram, from point A to point B, or you can say that at point A the liquid is converted in the metal is converted in liquid state, and point A to point B the liquid is cooled down, and the material is in liquid state. At point B the solidification start. Small nuclei formation starts. As you see in the diagram, there is small nuclei formation. Solidification starts at point B, and point B to point C the solidification process continues, and these small nuclei continue grow in a bigger size, and at point C it is completely converted into a solid state. So point B to point C is a transition phase at which the liquid is converted into a solid state, and at point B to point C is also known as temperature rest, because at this point the temperature becomes constant, and this is known as critical temperature. Point B to point C the small nuclei starts growing, and that's known as nucleation growth, and then dendritic formation, dendritic solidification starts from point B to point C. At point C the solidification ends, and the liquid is completely converted into a solid state, and the point C is known as freezing point, and after point C to point D the solid material is cooled down at a room temperature up to point D, and this is the microstructure which are developed after cooling, or grain structure which are developed after converting into solid state of the metal. So in this part we are going to study the cooling curve at different cooling rate. That means we are cooling down the material from liquid to solid state at a different rate of cooling. Diagram A shows the slow cooling, and diagram B shows the fast cooling. So the difference between slow cooling and fast cooling is that when the liquid from point A to point B the material is in liquid state, but at point B in a slow cooling the nuclei formation is very small. The number of nuclei formation is small, but in a fast cooling the number of nuclei formation is very large. Large number of nuclei forms in the liquid in the material, and when material process from point B to point C the nucleation starts growing, and in slow cooling as the number of nuclei is small, the grains developed are the number of grains developed are less in as compared to fast cooling, and in a slow cooling, because the number of grains or number of crystal structures are less, therefore the size of a grain or a microstructure is bigger in slow cooling as compared to the size that are developed in a fast cooling. Therefore, in a slow cooling, coarse grain structure are obtained, and in a fast cooling, a fine grain structure are obtained. So this is the one of the difference between between the cooling rate, slow cooling rate, and fast cooling rate. We will get different microstructure. At slow cooling rate, we will get coarse structure, and at fast cooling rate, we will get fine structure. So, and the next difference is that at a slow cooling, the temperature during the solidification process from point B to point C is known as solidification process. During this process, the temperature in slow cooling remains constant because cooling rate is equilibrium with the surrounding condition. But in the fast cooling, the temperature does not remain constant, or it goes below the critical temperature, the temperature which is also known as freezing temperature. And these two curves of slow cooling and fast cooling of same metal, but the cooling rate is different. Therefore, the freezing temperature or critical temperature is different for both the curve, because in a fast cooling, the rearrangement of molecules during freezing will need some more time to get converted into solid state. Therefore, it will dip down a slightly. The temperature goes below the critical temperature, and solidification starts. So this is the another difference between the slow cooling and the fast cooling of a metal. Next is the cooling curve for metal and alloy. As you all know, alloy is a mixture of two or more metals and non-metals with each other, and we form alloy to obtain the desired property according to their application. We are seeing here three curves: curve A, B, and C. Curve A is for pure metal, okay, and curve B and C is for alloy. But curve B is an alloy in which the two or more metals are mixed completely in liquid state as well as solid state. But curve C is a curve of an alloy in which the two or more metals are completely soluble in liquid state but incompletely or partially soluble in solid state. So in a metal, in a alloy cooling curve, the temperature or you can say the cooling temperature or freezing temperature does not remain constant, but in metal the temperature remains constant. This is the difference between the cooling curve in the metals and alloy. So that's all for today. In the next lecture, we will see the nucleation and growth during the solidification of a metal, and dendritic solidification during the cooling of metal from liquid to solid, and what are the effect of grain size on the mechanical properties of material. In this lecture, we see the grain size when the material is cooled very slow rate, the cooling rate is slow, then there is a coarse grain structure is obtained. But if the cooling rate is fast, then the fine grain structure is obtained. So what the grain structure affect on the mechanical properties of material, we will see in the next lecture. So thank you.